Hi, welcome to this module. We're going to discuss about SCADA, which stands for Supervisory Control and Data Acquisition. Three main subjects that we're going to cover are the basic application, the data management, and security. Hi, SCADA, which stands for Supervisory Control and Data Acquisition in systems, have been used in the utility industry since 1960s. SCADA is applied in many industries, and I'm going to specifically talk about SCADA in the power systems. SCADA application in the power system involves communication in a network. Communication has to cover a large geographical area. It have to cover a local and remote areas. The high cost of cables and installation would mean that the utility would have to use a more economical, would have to look for a more economical means like telephone lines, for example, leased lines or dial-up. In a leased line, it's an expensive investment because if the utility decide to use a leased line, it means that it has to purchase a line per substation, which is not a cheap solution. Dial-up can be used in circumstances where the substation is not a critical substation, and the information can be accessed on a periodic basis, like every hour, every half an hour, and so on. The remote site access adds a bit of a challenge in that there may not be physically a cable to that site or a third party that can provide services to that site, and then the utility would have to resort to radio access. Of course, the best solution remains to be the SCADA LAN. One of the common applications in communication is the power line carrier, or PLC referred to sometimes, which uses the transmission lines to transmit radio frequency signals in the range of 30 kilohertz to 500 kilohertz. The physical security of this communication is very high, since the power lines carrier equipment is located within the utility property, and as long as the utility property is protected, the communication, in this case, it's protected from hacking or access or external access. So security plays a big role in when we decide which communication media we're going to use in our architecture, in our SCADA planning. The centralized management system of a SCADA, sometimes referred to as DMS, Distributed Management System, or EMS, Energy Management System, would involve an HMI. Of course, an HMI stands for a human-machine interface. So basically, when this HMI would monitor or project a layout of the substations, and it would have the ability of producing a high-resolution graphics that shows the status of all the substations that are managed by the utility in a power system, and if there is an alarm or an event in these substations, it would be highlighted in this layout, and the operator will have the opportunity of either making a remote action to the substation or dispatching a person, an engineer, to the substation, so for the engineer to take a local action at the substation. Now, depending on the size of the substation and the layout of the substation, the local substation might have its own HMI that would allow the engineer to look at the layout of the SCADA internal to the substation and information that would assist the dispatched person in resolving the issue at the substation. The SCADA system allows also for document management, outage management. So when a utility incurs an outage for any reason at a substation, the SCADA system might have a component that will take care of answering the affected individuals and replying to them, keeping them updated with hourly information about the resolution of the issue based on the documentation release from the dispatched person or the local operator.
Controlling the electrical network and managing the people working on the grid is fundamental to a safe and reliable power system. GE's Power On Advantage is a modular ADMS built to deliver reliability, efficiency, and productivity gains through an intuitive user experience. Power On Advantage is built on over 30 years of grid management expertise. From daily advanced network control and optimization to crucial outage management events, Power On Advantage manages every step of the operation, including understanding the state of the network, to mobilizing resources, and then restoring the network. This intuitive system features an easy-to-use interface that displays analytics, action lists, dynamic maps, and a panel where the data finds you. GE's Power On Advantage builds an optimized ADMS cockpit centered around the operator. When an outage starts, grid information from substations, circuits, meters, and customers is communicated to the control center. Power On Advantage analyzes this data and can automate system restoration by initiating FDIR algorithms and executing switching to isolate the problem section of the circuit, quickly restoring as many customers as possible. With all the grid information centralized, Power On Advantage can see the big picture and enables the operator to make informed decisions, ensuring safe practices. The intelligence of Power On Advantage assists the operator in locating an available repair crew and directing them to the identified section of line. Communication is maintained between the teams in the office and the repair crews in the field. The restoration of the remaining customers must be done with precise coordination to ensure the safety of both the maintenance crew and the general public. With Power On Advantage, operators can clearly see the tasks and system status and are able to confidently proceed with the restoration. Power On Advantage has the flexibility to play many roles in a restoration. System restoration can be completely automated, or restoration steps can be recommended. Or Power On Advantage can simply manage the workflow and let the operator make the decisions. GE understands how you work and has designed a solution for safe, efficient, and innovative work completion that can be your ADMS, your DMS, or your OMS.
Over the years, SCADA has evolved from a monolithic architecture where you had only one framework where all the applications would report to a networked architecture. Today's SCADA systems are able to take advantage of the evolution from mainframe-based to client-server architecture. These systems use common communications protocols like Ethernet and TCP/IP to transmit data from the field to the master control unit at a very high speed. Unlike the older communication, which relied on low speed, and the expectation of the operators and the expectations of the utilities have been increased from accepting an hourly information to maybe seconds and sometimes milliseconds, depending on the implementation of the utility to collect data from the substation. Where the future of communication is going is to improve the information that's received by the utility in order to look at very detailed information like phasers and how synchronized phasers between parallel substations would give the utility operators a better idea and information in resolving the utility network power swings and react to it in a more effective manner than if the operator is sitting with 1 hour with an hourly information and responding to only hourly reaction instead of millisecond reactions response. So the utilities are looking for better ways to empowering their operators to basically resolve issues in the substations and in their power networks, and their expectations are much higher today than when it was in the 1980s and hourly information was acceptable. Okay, so we talked about communication, we talked about communication architecture. Once the communication has been decided, the layout of communication, the physical communication has been decided, there comes the big question of what protocol to be used between all the computers that are laid out in a SCADA system. Computers could be front-end processors or remote terminal units that are sitting in a substation, would communicate to the mainframe or the central management system using any of the common protocols. So there are common protocols that people got used to it over the years. For example, the Modbus, the IEC 6870-5-101, 103, 104, the DMP, Distributed Network Protocol, 61850, and of course the ICCP protocol, inter-control center protocol between control centers. So the ICCP protocol, the DMP, the 61850 are becoming more and more common, and utilities are trying to move toward a single protocol that serves the need of the entire utility. We have to take the history in perspective. These protocols were not available in the 1960s, and utilities were picking up devices on availability basis, and they ended up with a lot of protocols in their substations. So there could be about 3,000 protocols. So when deciding to what protocol is best for the SCADA system, it's very important to take in consideration the historical setting of all the substations. So all the protocols that are in substations, and having a strategic decision as to what is the best protocol that will serve the need of the substation, of the utility in the future, and what is the best economical application for protocols. From a protocol perspective, what is the job, what is the function of the protocols? As I've listed a couple of these functions, for example, you will have a station initialization, cyclic data transmission for all the monitored data, general interrogation, command transmission, data acquisition by polling, or data acquisition. Instead of data acquisition, you could have event acquisition, parameter loading. You might want to do a file transfer. And a key thing, if you want to collect data, is to make sure that you can compare this data. This data have to have the same time. So you might want to have a clock synchronization supported by the protocol, transmission of integrated totals, and of course a support for test situations and test procedures, and a support for any installation in the substation, where if there is an installation taking place, you want to put the substation in test or in no-monitor mode, basically. So these protocols, once you decide that a certain protocol has the right features and it serves the need of the utility, then what happens is you would start to converge all the devices toward that protocol in the substation and at the management center. So once we have decided on the communication, the media, the architecture of that communication, and the protocol to be used between all the computers, the next step is to decide as to how to manage the data that we're harvesting or we're receiving from the substations. The information coming back from a substation can be categorized as either an alarm or an event. An alarm is something that the operator might want to take an action on, whether the action is immediate action where a tally control needs to be issued in order to issue a change in the substation, or a person need to be dispatched immediately or in the near future. So the person might be dispatched at the start of the day or during a regular visit to carry out a certain task that would take out that alarm. If the info that is coming is an info that's going to be used in analysis or information that is to be used as a backup or by regulation requirements, that information could be stored as an event in the substation, and then once the requirement for this event information is comes up, then the event list is ready to be used. So one of the main jobs in a substation design is to make sure that you list all the alarms and you list all the events that are required to be communicated to the central management system. Sometimes this is referred to as the point list or the tag list or the point tag list. That's specified by the central management system and is given to the programmer of the main concentrator in order to make sure that the concentrator in its turn is doing the right job. For example, if a relay is giving 50 points or 50 alarms, maybe the operator at the central management system does not want to take a look at all 50 alarms, and all that's required is to OR all of the 50 alarms into a single alarm, and that single alarm will go back to the central management system, which indicate whether an immediate requirement or a remote requirement for a person to come to a substation to service the alarm. Once the decision has been made on what list the data should be categorized in, other decisions involve how often do we look at the data that's coming from the substation. So what are the scan rates? How many samples per second are required to be taken? And there could be software points that is required to be generated. I was in a project where there was a requirement to get the degrees centigrade from a degrees Kelvin reading, and that meant that we had a soft analog input that had to be created from a real reading in at the temperature sensor. So the pseudo points or the soft points, if you like, that has to be created and then transmitted to the main operator, the central management system, and the derived values maybe have to be calculated either at the substation level, at the concentrator level, or maybe at the management system level once the data is received before presenting it to the operator. And once you deal with many substations and many data coming from different sources, there comes the need for comparing this data. In order to do proper comparison, you would need the data to be properly time tagged. A time source has to be identified, and there is many time sources in the market today. So there is the SNTP, Simple Network Time Protocol, the IRIG-B time protocol, HOP, many other time protocols that can be utilized. And once you decide on the time protocol, you have to decide whether the time is fed locally or remotely, or both, locally and remotely, with a checkup in the protocol for the time that it's carrying out. How often does the substation require maintenance, and what is the maintenance cycle depends on the protocols and the devices that are used in the substation. What is the lifetime of these devices? How often an outage needs to be taking place? How often do we need to replace a piece of equipment? Is all part of managing the data in the substation and monitoring the data. Of course, if you're dealing with analogs, you would have to define the alarm zones, a high alarm versus a high alarm for an analog value. And how long does the alarm need to be in a certain zone before it is, how long does the analog value need to be in a certain zone before it is considered to be an alarming state? This is as far as operational data. Let's not forget that part of the data that's being collected in the substation includes non-operational data. The reason for collecting non-operational data, it could be done for a performance audit, that you're collecting data not for your day-to-day operation, but because you want to see what is the performance and the quality of power in your network. It could be a regulation requirement where the area where you're running your utility requires has a certain regulation to follow. It could be for billing purposes to customers in order to do a disturbance study, or when a fault takes place, what are the sequence of events that took place that led to that disturbance taking place, and maybe there is a trend in your substation that you need to follow after some time in order to find the cause of all the disturbances in your substations. There is many reasons for why non-operational data is collected in a substation, and it all has to be taken in consideration, has to be programmed into the main concentrator of the substation. So when we talk about SCADA, one of the central pieces that comes into play is how much of the data has to be managed and have to be concentrated in the main concentrator of the substation before it is transmitted over to the central management system of the network, of the utility network. Once we have categorized the data and we have specified the requirements for sampling and collecting this data, there comes the need for a specification around how to handle the historical data, how to manage this historical data. Is the data going to stay in the substation, or is going to be put on a historian off-site from the substation, so local to substation data storage, or a remote data storage at the central management system? There could be a server that's acting as a historian for all the substation's data, or for every substation we could have a single device that is basically recording the data locally. The other thing, depending on what geographic area you are in and the number of earthquakes that you face and whatnot, you may not want to keep the data just in electronic format, but would like to put it in a printable hard copy format, so that in case of a total disaster or whatever, the information can still be recovered in order to understand what led to the fault taking place. So it's a big decision whether to keep electronic and printable data or hard copy, and of course each decision would have its own cost and economics involved. for data. And then what do you do with archiving this data once you have, whether it's electronic or hard copy? In the old days when I used to be in substations, they used to have those recording tapes, and there might be still substations with these recording tapes to our date, and then I don't know where they're sourcing the recording tapes from, but CDs, DVDs, compacted DVDs. You would have to make all kind of logistics around how this data gets archived and where is the archived data going to be stored. So when a major event takes place, it's easy to access the data. A key thing also that has to be taken into consideration is the data analysis tools, and the accessibility to these tools becomes a key in a SCADA system. For example, take a consideration that a blackout took place, and now you've got all the people dispatched to the sites. They're trying to figure out what caused the blackout after the recovery from the blackout. And the first thing that comes to mind is, okay, well, we have to use the tool in order to look at this data. So we have all of this archived data now. How do we look at it? We need a tool to look at it, a special application, a special configuration tool to look at it. Where is the special configuration tool stored? And how can we get hold of it? If that application is available in the concentrator, it's part of the HMI of the concentrator, then that's very quick to access, right? And it's there for you to use. If that is sitting in a remote PC, or it's sitting on a DVD or a CD or somewhere in the cloud, and you have to download it and run it, you need that knowledge base to understand how to get your software and install it and run it. And this sometimes gets overlooked with time, right? People come into a substation, into a utility, and leave utilities, and managing these applications and tools becomes a little bit of a difficult task to do. So the protocol has to be in place when you have a SCADA system as to where to store your software, your analysis software, and your data. Not only the data, but also the software that's analyzing this data and allowing you to be able to open this data. The final part that we will cover is the data or the SCADA security. Now that we have covered how SCADA handles the communication and apply the communication, and how SCADA applies the data mining, how do we secure this data during communication? It's a big part and very important part in today's world. So when we take security into consideration for a substation, you have to think about what is the security attacks going to take place, and the possible attacks that are going to take place. And the best thing to do is to try to resolve it in rings of security. And how can you have a very good tactics in order to avoid a breach of the information or a downtime in your substation. It's not always about just the breach or the people getting at the information in the substation, or but it's about also the downtime. Maybe somebody is malicious enough to cause a failure or a downtime in a substation. So I would like to share with you a couple of the attacks, the classical attacks that used to take place against a SCADA network. So for example, there is the denial of service attack, basically where you would flood a server with requests, and that server will stop any operations except denying the service to the incoming requests. Now what that will do is it will bring down all communication between the main server, the central management system, and the local substation. And an estimate to recover from such an attack would be like 45 minutes or maybe a couple of hours. Now, when you're blind to your substation for a couple of hours, to the information in the substation, to the information in the alarms, that could be devastating as far as a network setup. depending on the sensitivity of the substation. Another malicious attack could be the delete of files, delete of event lists, delete of SOEs, delete of camera records, all of this information that's critical to the substation management. If it is removed, then that would cause a downtime. The estimated downtime for such a delete of system files would be a day or 2 days sometimes. The SCADA server might be have encountered a Trojan or a server Trojan application. When I was managing substations, one of the issues in the old days was a certain virus that would get transmitted through the use of USBs, USB sticks, and USB memory sticks would people at site, they're working, they find it easy to move information from one server to the other using a USB memory stick, and that USB memory stick has been used on a personal PC where there might be less of an antivirus software on it, and that virus would get to a machine in the substation and would stay there in the substation, but one day all the information in that hard drive might be wiped out. And all of that critical information might be lost. That information might be required for a regulation, so there is legal implications. And when you're managing a SCADA system, all of these protocols have to be cleared, that a USB stick cannot be used. And sometimes it has to be clarified not only as a policy on your machine, but also as a policy in your substation to all the workers in the substation. Even if the operating system prevents a person from using a USB, it has to be clear to everybody that nobody can use a memory USB stick because that might cause a bigger damage in your substation to the machines. Another malicious attack might be that somebody wants to get into the central management system, and one way to do it is by placing software that would record or log the keystrokes of the operator, and so once he gets hold of the username and password, then the entire management system is open in front of him, the entire SCADA is open in front of him, and then he can carry malicious attacks on the entire system. And then he would be able to pick up company sensitive or utility sensitive data information and use that utility sensitive data information to carry out certain malicious acts. So one big part is to avoid the downtime and loss of corporate data. Two things that are important: downtime, loss of corporate data. You are trying everything to make sure that the servers, the data in the servers cannot be compromised, and the servers don't go into a downtime at the substation. There is many ways to do that. You can implement a firewall. Every utility has their own local IT team that can put things in properly, and there is a lot of IEEE recommendations to allow utilities to avoid these downtimes, and it's highly recommended to follow these very strict security rules extremely these days with all the attacks that are taking place on the open internet. So when I talked about security, I talked about how to develop a security strategy, and I talked about the rings of security. So you have to look at the border of your communication. Where does your communication start? Where does it end? Where is your leased line start? Where does your leased line end? Where does your modem, dial-up modem start? Where does it end? And what devices need to be placed behind that. So you could have a firewall, you could utilize the proxy servers, make sure the operating system that you're using has a level C or higher security system. Your application policies, what applications are allowed to be used on your servers and the substations, what procedures in order to handle the programming of any application in the substation, and what is the SCADA operating system, the SCADA applications, and the SCADA policies and procedures that needs to be implemented in your substation and at the central management system. The strategy has to be clear to all the individuals that are using the system, and it has to be clear in the programming of the system.